All right, now that we have done two different search algorithms looking through a list, we want to move on and create two different sorting algorithms. And I've given you some examples here, but I think this is a good next step considering we were just looking through a list and now we need to look through a list and manipulate what's the order of the items, what's there. So these simulations I think are actually pretty good to show you what's going on. And I'm seeing for bubble sort here, we're comparing two items and switching them if they're out of order. And it looks like when one reaches the end, it's considered like locked in and it won't be looked at again. There are different strategies. For example, selection sort. This one's going to be a little bit silly at the start because I know what it does. It looks for the smallest item and moves it to the front, or at least to the frontmost position that is not locked in. So I'm going to just do these first two. You could definitely watch these, see how the other ones might work. This one has a strategy for pulling one out, finding where it goes in the list, and dropping it there. Merge sort is another strategy for it, and all of these have different pros and cons, but I want to start with bubble sort. So to identify exactly what I need to do, I know I need to go through the list and compare two at a time. And if they're out of order, swap them. If not, leave them how they are and look at the next two items. So I think I want to start with this unsorted list. Notice there's a non-sorted generator on this task, but at this first one, this is a sorted list. So I want to generate the non-sorted list, but I'm going to use the same snippet of code to find the bots. So I'm going to make a little button here. When I click on it, on click, I want to run this code where I find a list of bots. Now I am sorting this list, but remember this sort happens based on its position, not how big the number is. So this will be a list of bots in order from left to right. So I want to type out some comments letting myself know what I should be coding and see if I can come up with a strategy to create this. Now, if you want, you could definitely take a look at the code that's given here for how it's doing the sorting, but this is a different coding language and there's some context around this that we don't have. So if you want to use this as like a template for what you should be coding, go for it. But what I'm going to do is just try and come up with this from scratch because I get the process and I know I need to compare two items. I need to swap if they're out of order, and I need to move on to the next two items. Now, I know I need to do this. I need to go through the list, swapping the items until I get to the end. And then I know I'm going to need to like lock that last one in and then go back to the start. So maybe there will be like multiple loops here. I'm not sure yet. But I kind of want to cross that bridge when I get to it and see if I can just walk through the list, comparing two items at a time and swapping them if I need to. So we could do a for loop. Remember, we've done for B of list bots to check each and every bot. But that only gives us one bot. We could modify this a little bit and find the index, each of the indexes in the list bots. Now, why for in and for of are different? They're useful in different circumstances, but keeping track of if you should do for in or for of, you might just have to Google for the first couple years that you're coding in JavaScript because it's hard to keep those straight. I actually want to back out and try a completely different strategy that I haven't tried in class. I haven't shown you how to code like this, but it feels appropriate for this and a little more fundamental in terms of looping through things. We don't need to think about ofs or ins or anything. So I'm just going to say first index should be 0 and second index should be 1. Then if I want the first and second bots, we just need list bots, first index, and list bots second index. So I might make this a variable, say first bot equals that, and second bot equals that. And then I'll be able to reuse this if I can just change these numbers. So I'm identifying which bots to look at. And since we're trying to simulate this, I'm going to take their tags.color and make them yellow. That way I'll be able to visually see what I'm looking at. And then I'm going to add a little pause in here, maybe just a quarter of a second. And I need to compare them and swap them if they're out of order. So I'm going to do an if statement in here. We'll put the swap. And how could I compare these? Now the first bot, instead of its color tag, I want to look at its label tag. And I want to check if the first one is bigger than the second one, then I want to switch the position. So how could I switch the position? My intuition, when I'm coding something like this, kind of tells me I want to take the first bot's home X tag and make it equal to the second bot's home X tag. That'll bring the first bot to the second bot's position. Now, we also need to move the second bot to the first bot's position. There's something wrong with this though, because if this line of code runs, I move the first bot to where the second bot is, and then I try to move the second bot to now the first bot has moved. So somehow I'm going to need to keep track of where the first bot started. So I'm going to make a variable called first bot position and set it equal to its home X tag. And maybe it would be more accurate to say first bot home X. Maybe it'd be simpler just to say first bot X. Maybe it'd be even simpler just to say first X. So this is the number I want to set the second bot's position to. To me, this is a little goofy to move them in different ways. Like, I think it would be a little more consistent if I said first X, second X, and then it's pretty clear. I'm figuring out what the positions are, and then I'm setting them to each other's positions. Now, if we are worried about this growing out of scale, we could move this to another function. I'm not going to do that just because I'm still working out exactly how I'm going to approach this problem. So I'm just going to leave this all in place. And if I want to edit it and make it cleaner later, I can. So I'm going to compare two items. If they're out of order, swap them. And then I'm going to need to put their colors back to normal so they don't just all turn yellow. So I'll turn them both back white. And then I need to move on to the next two items. So I could do that if I say first index, I don't need to let it equal anything because letting starts it, it creates it, it makes it exist. So I know this needs to turn into a 1 and that needs to turn into a 2. What I could do to make sure this is a little more robust is say it's equal to what it is plus 1. Now this could work regardless of what number first index is at, because I know it will be changing. A faster way to write this, programmers love shortcuts, is to say plus equals. Plus equals 1 means set it equal to 1 more than it was. So I want to check this just to see if it swaps like I expect, and it doesn't. So first thing I'm going to do is check for errors. No errors. But why did I have this expectation? I don't know. See if it swaps them like I expect. 79 and 91 shouldn't swap. Let's try this, see if they swap. All right, so it can swap the first two, but it's not ready to look through the whole list yet. Why is that? Well, because we're just gonna read all these lines down and not go back to the top. So I'm gonna wrap this all in a while loop. Now, what should we use for the while loop? I think, for now, I just want to stop when we're at the end. So, I'm going to check if the second bot exists. Should I check if the second bot exists? I could check if the second bot exists. Maybe we could check the type of the second bot and see if the type is equal to an object. JavaScript actually has a lot of shortcuts, a lot of ways that it tries to understand what you mean. You can actually just check if second bot, and if second bot exists, then we do this. You can check if not second bot, then we want to say done is true. But done doesn't exist, so I'm going to click up here, say let done equal false, and then I'm going to type well not done. Notice if you watched the last video, I did like a still searching or swapping and let that equal true. You can do this either way around. While swapping, then I would have to say swapping is false. I just like to type it a couple ways so that you see there are options for all of these things. We could also, before even trying to find the bot, we could check if the second index is greater than the length of the list. Now, remember, indexes always start at 0, 0, 1, 2, 3, 4. So a length of 5, you have 5 items in it, the final index would be 4. So instead of checking if the index is bigger than the length, we could check if it's bigger than one less than the length, which would be the final index. Or you could check, is it greater than or equal to the length? So if I have a list that has 0, 1, 2, 3, 4, those would be the indexes, the 0th item. The second item is actually the third item. All I want to know is this index going to be too big? And so if it's equal to the length, 1, 2, 3, 4, 5, we're out of bounds. I'm going to see what happens. I'm seeing some swapping. I'm seeing some bots turning yellow or staying yellow back at the end, and I'm not totally sure why that's happening, because it seems like they should always turn back to white. But there's a little trick that's going on here. It's not actually always comparing the two that are next to each other, because the order of list bots isn't changing. We're moving the bots, we're changing their home X tags, but we're only sorting them up front. So I'm going to copy this sort and make sure it gets sorted before we try and do any comparing or switching. Now the two are turning yellow together, and it's going through, and it looks like we've successfully sorted the last item. Now, we could figure out a way to lock it in. I think probably if we're just trying to simulate and show what's happening, we can simply do that by just looking through the whole list again. And if we look through a part of the list that's already sorted, that's okay for now, because we'll be closer if we can at least sort the list. So instead of being done swapping, what I think we should do, if the second index is bigger than the length of the list, let's just set them back to the start. And this will probably go on forever. And that's okay, because I know if I refresh the page, it'll stop. So swapping is true. While swapping, we never set it to false. That while loop is going to keep going. I just want to see, will it keep going and sort through this list? It makes it to the end and goes back to the start. That's good. And I think it's bringing the correct number all the way to the end. So I'm probably going to speed this up because I kind of get what's happening. I see it's checking the correct ones now. But I also see it is still checking all these numbers at the end that are sorted. So I'm going to speed it up. Oh, and I also want to stop it. So I'll refresh the page and generate a new list for us to sort. Now, how could we lock one in at the end? So if the second index is greater than or equal to the length, what I want to do is I'm going to take the listbot's first index. Remember, the second index is out of bounds, so the first index should still be a bot. I'm going to take that, get its tags, and set its color equal to green to say it's done. Then we could maybe do a check at the front, like if either of the bots are green, skip, continue, whatever. But I remember from the last video that I did where we did the binary search, I was able to cut these things. So what I want to do is figure out in JavaScript, how do I cut the last item out of a list? I remember it was called splice, but it looks like there's also an option called pop. And pop does exactly what we want. Removed item equals fruits.pop, but fruits got changed and it no longer has date at the end here. And the removed item is date. So I think what I'm going to do is just say listbots.pop and take it out of the list. I hope this works. I've never tested it. Well, it didn't turn green and is still sorting through everything. So something in my thinking is wrong. What am I thinking that's wrong? Probably I set the first index back to 0 and then I found the first index bot. So let's take the first index before I change it. See what happens. All right, now they're turning green. It looks like we're still checking to the end though. So maybe it isn't actually removing the bot like I expect it to. So I'm just going to, every time around, toast listbots.length. See if the length of the list is changing at all. So it's 20 items, 20 items, 20 items, 20 items. For some reason, pop is not acting like I expect it to. So I'm going to try this other method because splice was working before. -1, I'm assuming if I do a splice like this, oh, I figured out what I did wrong. If I do a splice like this, I'm assuming the minus means count backwards and the 1 means remove 1 item. But if you caught it before me, great job. I said pop, but I never made the function happen. So let's generate a list and see how this works. It's 20 items, it's 19 items, So now we're locking them in when we're done. So we just need to figure out, should we ever just be done? How can we check when the whole sort is complete and everything's in order? Well, we're removing items over and over and over, so it's going to break at some point because there's only one bot left. It can't find the second bot. So I'm just going to quickly check and say if listbots.length is equal to 1, then I'm going to say swapping is false. I should probably do that right after I remove a bot from the list. How about that? I'm guessing we might still have an error if we watch the console, because we're not actually exiting the while loop as soon as we turn that to false. It checks if swapped is still true, or if swapping is still true when it tries to restart. So we still have an error and we're still trying to do things that we shouldn't. So what we could do, I'm going to get rid of this message because I don't need it anymore. We could say else and wrap all of this that we're doing in the else, so it only tries to swap them if it, after all of this is completed, after we've done all our checking. But I think really simply, instead of setting swapping to false, we could just return. Get out of here. We don't need to be doing anything in this function anymore. I gave myself an error, unexpected token on line 48. Sometimes, especially in the version that's not hosted at school, it loses some of your typing if you do it too quickly. I refresh to get myself back in sync with what's happening and then pasted in what I was seeing before, so that was able to fix that. So we can return out of here. We could wrap everything in an else, or we could do this check after we change the index before we start the loop again. So maybe we have swapped the items, maybe we haven't, but we'll sort the list again down here and then check if we should put the indexes back down and change the colors and get out. So I could set swapping equal to false here, and because everything goes in order, we're going to go down, 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 set swapping false, and then this won't happen again. So there are several ways to solve that problem, and I just kind of rambled them out at you with hopefully equal emphasis. If I'm solving this problem, I think I would solve it this way, because I've created a variable to check if we should be swapping or not. And so I'm going to use that variable. If I wanted to not, then I could just say something that's always true and say return here. It's up to you how you want to solve problems like that. But for now, this works. This accomplishes our goal. So this is the end of the video.